All right. Well, welcome back again, and we're talking about finding arc lengths and central angles. What you may or may not know is when you talk about central angles and arc lengths, you learned about this in geometry class. In that, when you have this, really, whenever you have an angle, we are always comparing that to the whole circle or whole angle. So, for example, if I want to find the arc length of this little part right here, and this is referring to the angle. It's not written very well, but we got that a little better. We're talking about this angle. Well, we can say, all right, the angle right here is to the angle of the entire circle, which we know is 360 degrees, and that is proportional to the arc length, which sometimes in your books we call S, okay, over the entire arc length of the entire circle. Now, that's known as the circumference. Okay, so how do you find circumference? That's 2 pi r. Now, in doing this, if we have r right here and we want to figure out arc lengths, we cross multiply. And what you realize is that you have theta over 360 times 2 pi r equals s. I'll just say that s is arc length. And then you notice that 2 goes into 360 and that turns into 180. And then you realize that you have this right here, r. And if you're in trig class, you start to realize, hopefully you'll realize that pi over 180 times an angle in degrees, so that's the angle in degrees, all right, times pi over 180 is actually a radian measure. Oh, okay, it's a radian. And so the radian times the radius equals the arc length of a circle. So the radian times the radius equals the arc length. And many times you see in books where they say theta times r equals s. And we use that. The key thing is that the angle you're doing for arc length is a radian. So using this knowledge of a radian times a radius equals arc length, we can find either a central angle or anything that we want from here. So for example, if I want to find the central angle, and I'm given the arc length, which is 6, well, I know the central angle is theta in radians times the radius, which is 27. And I can find this radian measurement taking, all right, well, 6 divided by 27. That is my arc length in radians. If I want to convert that into degrees, I would take 6 over 270 times 180 over pi, and that would give me my degree. And if you check it out and you put in your calculator real quick like a fox, all right, you can have 6 times 180, all right, divided by 27, and divide that by pi, and you have like 12.732. All right, like I say, that's what I got, 12.732. All right, that is our degrees in doing so. And that's how we go. And that's how you can figure out an angle or central angle measure and whatnot. Now, let's say you want to find arc length. Well, if you have a central angle which is in degrees, we can actually use this, what you learned in geometry, this formula right here, okay? Or you can use the trig formula, which is S equals, that's arc length, times the radian, times the radius, equals arc length. And so if we're finding arc lengths, we can say, okay, my radius is 9 times my, well, this is where sometimes students get in trouble. They just put 60 here, but that is a degree. We got to make that into a radian. So we got to multiply that by pi over 180 degrees. And so what we have then is going to be 60 times pi times 9, all divided by 180. And what you should get is 9.424. 424. That would be feet. All right, that would be feet. And that is our arc length measure. And that's how we can figure it out. So whatever you have, whatever you're looking for, all right, if you're given a degree, and if you're going to have this, and we are going to have, okay, what is, all right, the arc length of this shaded region right here. So I want to find this arc length. Sometimes this is a tricky problem. So I want to find that arc length. All right, I'm given my radius measure, which is, I don't know, let's just say 3 inches. Okay, and I say this is 23, all right, degrees. And I want to find out the green arc length measure. So I want to figure out this, oh, maybe purple, this arc length measure all the way around. What do we do here? Well, hopefully you can maybe think about this. Give me a second. All right. Well, I need to find this angle measure. I need to find that angle measure. Well, how do I do that? I need to take 360 minus 23. All right, minus 23. And when you have that 360 minus 23, all right, that's going to be 337. 337 degrees. And so, in order to find this arc length of 337 degree angle times the radius, which is 3, I remember I have to take that and make the radian. I have to make that a radian. And so right here, that's what I have. And so I would take 337 times pi, all right, times 3, divided by 180 in this case. And I'll have my arc length of 17.645 inches. And I use my calculator I have here. There we go. Okay, and so, moral of the story, when you're dealing with arc length application in trigonometry, you'll probably be asked to find central angles and arc lengths. Many times they put you in the book to give you theta times r equals s. That's a radian times a radius equals, that's hard to say, radian times radius equals arc length. Remember, the radian measure, if you're given degrees, you take pi divided by 180, or just take that, whatever it is, and you can solve that. Okay? Little things to help you out, make your life easier in the future. All right, well, I hope this helps you out, and yeah, give me a thumbs up, and we'll talk to you later. All right, bye.